that, we have to understand a few fundamental properties of light. Okay, now light is, I'm just going to show this part of this slide right now. Light is described in terms of waves. We use this, the reason why we use waves to describe light is because waves exist in a lot of different places in the natural world, and so mathematicians have developed mathematical models to describe the behavior of wave-like behavior of various substances, whether that be sound moving or water waves or light in this case. And so what we understand then, some ways of describing different waves, is to describe the wave by its wavelength. And the wavelength is the distance from peak to peak or trough to trough. It doesn't matter. It's the same. So you can either measure from peak to peak or trough to trough. That's the bottom of the wave versus the top of the wave. And that's called the wavelength. And you can see these two different waves are described by their wavelengths. This wavelength is longer than that wavelength. And the other way that we describe light is by the frequency. And what that means is the frequency, how many peaks pass, because these waves are traveling in space. They are not static. These waves, the types of waves that are associated with electromagnetic radiation or light, are moving waves. And so they're moving through space. Actually, light travels, the speed of light is constant, in a vacuum. And so they're moving at this constant speed, but the wavelengths are different. So the frequency then is telling us how many peaks pass a certain point in time of the longer wavelength versus the shorter wavelength. And you can see if these two waves were traveling at the same speed, that the number of peaks that would pass, say, this point in time on the long wavelength would be fewer peaks than the number of peaks that would pass this place in time for this shorter wavelength. All right, so then the correlation is that the longer wavelength has a lower frequency, fewer number of peaks passing the point at a given time, and the shorter wavelength has a higher frequency. And frequency is expressed in units of 1/2. Wavelengths are expressed in a unit, a length unit, some meter. But the frequency is always expressed in 1/seconds, and also that's the hertz. The hertz is a frequency unit, so sometimes you'll hear, 95 hertz, or it's the same as 95 1/seconds, or per second, is sometimes how it's described. Now there's this relationship between wavelength and frequency, and it's a fixed relationship, and that relationship is that the frequency is equal to, this is the abbreviation for frequency, it's a little new, is equal to C, that's a constant, and that constant is the speed of light in a vacuum, divided by lambda. That's the wavelength. Okay, and so the speed of light is really 2.99 something something something, but it's okay to round it off to 3 × 10⁸ meters per second. That's the constant, the speed of light in a vacuum. And then the frequency, of course, the unit is going to be 1/seconds. And then in this relationship, the wavelength unit has to be expressed in terms of meters in order for the units to work out with this constant expressed in these units, meters per second. So that way, meters per second over meters equals 1/seconds, and so the units will match on the left-hand side and the right-hand side. So given some wavelength in meters, you can calculate the frequency, or given the frequency in units of hertz, 1/seconds or per seconds, you can, knowing the speed of light, you can calculate the wavelength. So back and forth is this relationship. It's an inverse relationship. This is the constant, and this is the relationship. As the wavelength gets longer, the frequency is lower. Okay? All right, so that's just one way that we describe. So if you hear people talking about the electromagnetic spectrum and parts of it in units in terms of wavelength or frequency, it's just a way to talk about the different parts of the spectrum, because the electromagnetic radiation has properties that are similar to waves. So you can use the wave math and wave properties to describe the different parts of the electromagnetic spectrum.